Hey guys, it's time for math. Yay! Actually, good morning and welcome to Thursday. And I did post this a little earlier for you early birds. Ethan, Colin, who else was up at like 6:45? I forget. Y'all are crazy. Miss Offit is definitely not up that early. But I am up pretty late at night, so that's okay. So anyway, today we are going to continue talking about two more properties, the inverse property and the distributive property. Inverse, super easy. This video will be real short. And then the distributive property is kind of tricky. Okay, so that one will be a little bit longer. I might break it up into two, but it's going to be one you might need to go back and do twice. Let's see. Okay, so let's start with the inverse property. Oh, and my camera's a little blurry. Let me see if I can. Oh, that's better. Okay, so again, I've got my interactive notebook, or my spiral. Not interactive notebook, sorry. My brain hurts. And just like the commutative property, we use the word commute to remind us that it changed positions. And the associative property, we used, I forgot, what word did we use? Grouping. Okay, what group were we associated with? Okay, and then inverse, this mirror, it's kind of a weird analogy, but I get it on the addition one. It's a little bit hard for me to see it on the multiplicative inverse one. But anyway, so inverse property. What is the inverse property? We've actually talked about this additive inverse idea before when we were doing integers and talking about zero pairs. Like we talked about if you had -3, remember the little magnetic counter pieces that I could put on the board, and the yellow ones were positive and the red ones were negative. And if we had 3 positive counters and 3 negative counters, I'm sorry, 3 red ones, then they kind of canceled each other out. Okay, so that's basically what the additive inverse is. So we're actually gonna give it an actual definition. We're gonna say it's the sum of a number and its opposite, okay, is equal to 0. And you might want to put a little note out to the side reminding you that we actually did learn about this. We called it zero pairs. Like, one yellow and one red made a zero pair because one positive and one negative canceled each other out. So just like the other day, on Tuesday, we were talking about these other words that you need to like highlight or make sure you really remember these vocabulary words, because you're going to hear additive inverse probably more common than inverse property of addition. You're going to hear what's the additive inverse. So this is a really important vocabulary word that you kind of start getting into your use. Okay, so the example or the little equation, because we always use like an equation with variables, it would basically just be like a plus -a equals 0. So it could be 3 plus -3 equals 0. 1 plus, so we can write a few examples down. We can do 3 plus -3 equals 0. Or, 14 plus -14 equals 0. So pretty much it. A number and its opposite equals 0. So those are the main things you want to remember there. 0 pairs. That's not difficult. Okay, then the inverse property of multiplication is also called the multiplicative inverse. It's just fun to say multiplicative. Okay, and I'm going to make sure I highlight that in my notes so that I remember that word. Because as you go further in math, you're going to hear additive inverse and multiplicative inverse more. It's going to be more commonly used than just saying the inverse property of multiplication. That's just too much. So be familiar with that term. So what is its definition? Okay, it is, we're going to describe it by multiplying. Sorry, my voice is changing. Multiplying a number by its reciprocal. Let's write it down here. Reciprocal. We're going to have to remember what that word means. Maybe y'all remember. Hopefully you do. Results in a product, of, what do y'all think? 1. Okay, so what do I mean by that? Okay, so here's our example. A times 1 over A is equal to 1. Now you may also see it written like this, just A times 1 over A equals 1. Because remember we talked about in algebraic expressions, they don't necessarily always use a multiplication sign. Actually, rarely do they. Most of the time it's just going to be the variable outside of parentheses tells you that they're being multiplied, or just a variable next to a number tells you they're being multiplied together. They don't sometimes use a dot, but they don't really use the multiplication sign because it looks like an X. So we don't want to confuse that. Okay, so what's an example of that? Well, it could just be 7 times 1/7 equals 1. Okay, remember reciprocal when we were doing dividing fractions? If we had like 1/2 divided by 1/3, we did the keep, change, flip, and you were flipping. If it was 1/2 times 1/3, you were flipping that 1/3 to its reciprocal, which would be 3 over 1. So 3 over 1 is just kind of like its opposite. So I think the reason why we use this mirror phrase, or the reason it makes sense to me, is because mirrors, think about when you're looking in a mirror, you can see, like if I was going to hold up words in a mirror, you see like the opposite of it. It's kind of backwards sometimes. Like if I were to, well, actually this will be okay. But certain times, because it's not a mirror, if you try to hold up something in a mirror, things will be backwards. So it's kind of like an opposite reflection. So since these are adding opposites and getting a 0, and these are multiplying its reciprocal, which is kind of like an opposite, you get 1. That's what we just kind of talk about mirror. What's another example? I could do 20 times 1 over 20, and that would also equal 1. Why does it equal 1? Well, because if I do 7 times 1 over 7, that's the same as if I'm going to multiply a whole number by a fraction. That is a 7, not a 1. I put a 1 underneath it, and then I just get 7 over 7, which is equal to 1, right? So you guys know that. So, and these came up a lot in when we were in class together, and I was giving you Greg Tang puzzles. I miss those days. I miss you guys. Anyway, a lot of the snake puzzles, you guys were just having to multiply whole numbers by fractions. And basically, you're just going to take this whole number and it ends up on top because you have a 1 on the bottom, and then you simplify. Okay, so super, super easy. Okay, so I'm getting ahead of myself. I have a lot of things ready. So these are the practice problems that I want y'all to do. So on the next page, or just on the back of the page you just took notes on, I want you to pause the video, and I want you to just really, really quickly see how fast you can fill these in. And then when you're done, unpause the video and see how you did. Okay, pause. Okay, I'm assuming you unpaused if you can hear me. All right, so this is really easy because basically your answers are either going to be 0 or 1. Okay, if it's adding opposites, you get a 0. If it's multiplying the reciprocals, you're getting a 1. Okay, so these are opposites, it's a 0. This is, we just did this one on the other page. It's a 1. 32 times 1, that's a 1. This one, 0. This one, 1. This one, 0. You should have been able to do that really quickly. If you're not understanding this, let me know, okay? But like if I just wanted to show one more out to the side, if I did 32 times 1 over 32, okay, I'm basically going to change this to a fraction if I have a whole number and then multiply across. 32 times 1 is 32. 1 times 32 is 32. 32 over 32 is 1. So just in case you were like, wait, why are you getting a 1 every time? Okay, so that's it. This lesson was very simple. So I'm going to end this video, and then we'll start one more with the distributive property. So get a drink of water, go to the bathroom, do what you need to do, take a deep breath, and we're going to do the distributive property. All right, see you in a second.